Scientists developed a flowing model for the interactions of charged particles operating in a complex two-dimensional magnetic field where x and y are the position of the charged particle. Use the following non-linear system, this one that we have at the bottom here, to answer the questions below. And part A, find all the critical points of the non-linear system. Now, remember from previous calculus courses, what is a critical point? Is a point where the slope is 0. These are first order differential equations. So this left-hand side is the slope for that particular quantity. So if we set that to 0 and this to 0 and solve this system, we should find all the values of x and y's that combine such that they give us that the first derivatives of x and y are 0. And those paired up are going to be our critical points. Now this is a non-linear system, so it might have more than one answer. And so, sorry, more than two answers. Because if this was just linear, we'd have an x and a y and that's it. So I like to put this in Matlab just to make sure that I don't miss one critical point. So let's go over to Matlab and let's put it in there. So first thing, we're going to clear all old variables with the clear all command. Then we're going to define new variables, and we're going to be defining with the sims command x and y, and then we're going to solve for the critical points of the system. So we use the solve command, and we're going to put in 0 is equal is given by the double equal sign in Matlab, x minus y minus x squared plus x times y. We're going to define the other one as well, separated by a comma. 0 is equal to negative x squared minus y. We could have done this by hand, but I just want to show you how to do it in Matlab. And here we're going to have our x and a y, which is, this is specifying what we're trying to solve for. And then here I like to add real and true, because for the critical points you only want true solutions. Sorry, not true. You'll only want real solutions, meaning no imaginaries. And now you want this to output in your x sol and y sol. I named them differently because I like to keep them separate from the variables. So now we press Control Enter, and we see what Matlab gives to us. It gives us 3 critical points, and these are paired up. So the first entry in this vector corresponds to the first entry in this vector. So 0, 0 is a critical point, and that makes sense because 0, 0 in a slope field is always a magnet, because once you're at 0, you really cannot change or go anywhere else. So 0, 0 tends to always be one of the critical points. So that lets us know that we're on track. Then we got -1, -1, and 1, -1. So we would write these, and I would also do it by hand to show my work. And that's it.